Okay, today we're going to talk about prime factorization. But in order to talk about prime factorization, we have to first talk about what a prime number is. So a prime number is a number whose only factors are 1 in itself. So for example, the number is 7. 7 is a prime number because the only two numbers that you can multiply to get 7 is 7 and 1. Okay? Whereas number 4 is not a prime number. Number 4 is not a prime number because you can multiply 2 and 2 and get 4. And you can also multiply 4 and 1 to get 4. And since you can do something other than 4 and 1, it is not prime. Alright, so what I did was first write the first few prime numbers out of 100. So I have 1, 2, 3, 5, 7, 11, 13, 17, and 19. Alright, so those are our first few prime numbers. Now, we're going to start by doing the birthday cake method by actually doing an example. So the example we're going to use is 175. Alright, notice I started at the bottom, and that is for a reason because we're going to be working our way up. So what we want to do, and the idea of this, is to find prime numbers that can divide the number given. So we have the numbers up top, so we got to pick a number out of the top that would divide 175. So of course 1 will, but we don't want to use 1. We want to pick another number. All right, 2 will not divide 175. 3 will not divide 175, but 5 will divide 175. All right. 5 will divide 175. And when we divide 175 by 5, we get 35. All right. So we have a whole new problem. 35 is up top. So now we got to find a prime number that will divide 35. 1, of course, will. 2 will not. 3 will not. But 5 will. All right. When we divide 35 by 5, we get 7. All right, now we got 7 up top. We got to pick a prime number that will divide 7. 2 will not, 3 will not, 5 will not, but 7 will. And 7 is also prime. All right. Now, when we divide 7 by 7, we have the number 1. And that is exactly what we want at the top of our birthday cake. The 1 is kind of like our candle. When we have our 1 up top, we know we're done. All right, so this is all our prime factorization. The prime factorization of 175 is 5 times 5 times 7. And there you have your prime factorization. Now, let's go do another problem just to make sure that we have it. All right, so let's flip screens. Next example is going to be 63. All right, so I'm going to write the prime numbers up top. 1, 2, 3, 5, 7, 11, 13, 17, and 19, because we're going to need those. All right, so we have 63. We want to find a number that will a prime number that will divide 63 starting at 2. 2 will not, and 3 will. All right, so when we divide 63 by 3, we get 21. Now, I'm going to start all over back at 2. 2 will not divide 21, but 3 will. And when we divide 21 by 3, we get 7. All right, 7 is prime, so we know only one number can divide it. That's other than 1, which is itself, and that's 7. And when we divide 7 by 7, we get 1, and we have our little candle. So the prime factorization of 63 is equal to 3 times 3 times 7. And of course, since multiplication is commutative, that can be in any order. But the 3 numbers that we multiply to get 63 is 3, 3, and 7. And there you have it, prime factorization using the birthday cake method.